Hello, and welcome to this series of videos in support of this Materials Made Smarter outreach demonstration of how computer vision and machine learning can be used to recognize different materials to make recycling easier. My name is Dr. Robert Gibbs, and I have developed this demonstration with Professor Giannetti of Swansea University for Materials Made Smarter. Documentation about the theory behind this demonstration and instructions on how to use this demonstration are available at Discover Materials by scanning the QR code. Also available on the Discover Materials website, an electronic version of the printed booklet and further information about the code, the equipment, and progressively more detailed project documentation. In this fourth video of the series, we will look at retraining the model to improve performance on examples of cans, bottles, and coffee cups it has not seen before. I assume that you have the system up and running in accordance with the first video of the series. So we have the system running, we have the live video feed. The model isn't trained or loaded in. Where we've previously saved our trained model, we don't need to rerun our training. We can press the load model and watch for the little black dot up here to tell us that the load is finished. And then instead of training now, we're going to evaluate the model that we've just loaded in. And this still takes a bit of time because it still has to load in the ResNet 18 model. It still has to load our saved file into the final layer of that ResNet pre-trained model to give us our working system, but it takes a lot less time than training from scratch on our dataset, as we did in the second video of this series. So as the progress bar comes to the end of loading in and evaluating the model that we've just brought in from the saved file, it's saved up there, the system again switches to the predict mode, ready to recognize the objects we put in. So if we put in the can that it has been trained on, it recognizes it as the can, 99% confidence. If we put in the bottle it has been trained on, it recognizes the bottle with 100% confidence. And the coffee cup it has been trained on, it recognizes the coffee cup with 99% confidence. And then again, if we experiment with putting a can that it hasn't seen before, it recognizes it as a can, so there's something common to both cans, even though they're different colors. Only 97% confidence, but that's still very confident that it can see that can. And a bottle it hasn't been trained on, you can see 100% confidence, so it has a good understanding of all the features of a bottle. What do you think is common in bottles that is different to all the other objects, that it's easy to recognize them? Now if we try a coffee cup that is different to the one it has been trained on, now it is confused about that object and what it is. There must be something in the coffee cup that it has been trained on that it recognizes happily that isn't in this coffee cup. In this case it did recognize it as a coffee cup, but you can still see only 74% confidence. This coffee cup is a new coffee cup it hasn't seen before, and it can easily be confused. It's still recognizing it as a coffee cup, only 55% confidence, and a lot of confusion that it might be one of the other objects. As it did the first time round, it didn't think it was the coffee cup. So how can we improve this situation on objects it hasn't seen before? Well, the key to that is giving it some more training images on new objects so it can get a more general idea of what a coffee cup is and be less confused. So what we're going to do is go to kernel, restart kernel, and clear all outputs. This will just stop the machine for a bit. What we want to do is just give it a few extra images of what a coffee cup looks like, and maybe also what the can and the bottle look like. But we don't want to damage our original data set here. I want to keep that intact. But I don't want to have to repeat the 50 images of the objects it already knows. So I'm just going to use the terminal to make a copy of that dataset. We're going to call it dataset B. In the terminal here now, if I list ls, we can see this is the base level of the file system. If we change directory cd into data and then list again, we can see the files that are present here. And we want to go into images, so we change directory into images. And we can see our first data set is there. Now I want to make a copy of that data set so I don't have to repeat the 50 images I've already made. So we want to make a copy recursively of everything in the data set, BCCA, and we want to copy it to BCCB. And now when we list the directory, we have a duplicate copy, BCCB, of that folder. And if you put the console down, we can go back to Jupyter Notebooks. We can see that duplicate dataset is there. Now we want to run the system again. Restart kernel and run all cells. Restart. Give it time to get up and running again. We have the live video feed. We are in training mode. At the moment we're looking at dataset A. If we go to dataset B, which we've just created a copy of, we can see that there are already 50 images in each of that dataset as well. So now we can work on dataset B and we can add 10 more images of different objects. We'll start with the new bottle. And we press capture image, and you can see the number of images has gone up to 51. It's always a good idea to have an equal number of images of each category to give yourself a balanced data set. So this is why, even though the system was able to recognize this as a bottle, we're just adding this new one so that it has 10 more images of a bottle. And then we want 10 more images of the new can. More images of the new can. 3 more to go. Try and get different orientations of your images. Okay, and then the more important, we want 10 images of our different coffee cup. And having sped up taking these pictures for you on the video, we now have 10 examples of that coffee cup. And we're going to see if that helps the system recognize that coffee cup better. So again, with 10 epochs, we're going to train the system on dataset B, 60 images, and see if that helps it to recognize the coffee cup that it had trouble recognizing before. will speed up the training process again. Okay, and after training has been completed, the system's moved back into the prediction state. So let's try it predicting those objects. The can. First time it recognizes an object, it has to load the system into memory, so that's quite quick. Recognize the can, 98% confidence. Recognizes the original bottle with 99% confidence. Recognizes the original coffee cup with 100% confidence. Recognizes the new can with 100% confidence. Recognizes the new bottle with 100% confidence. Oh, sorry, 88% confidence. And then finally, does it recognize the new coffee cup better than it did before? Yep, 95% confidence on the new coffee cup. So you can see in this straightforward demonstration how it's possible to retrain machine learning just on a few extra images to really improve its understanding of a new object without having to train from scratch every single time on exactly what a can, a cup, or a bottle is. So have fun playing around with the demonstration, and I'll see you next time.